Hi everyone, welcome to another episode of Common Lisp Study Group. I'm your host Ron Vadum with Atlanta Functional Programming. Last week we covered Chapter 4 of Paradigms Artificial Intelligence Programming on the General Problem Solver, one of the first kind of systems that introduced us to this realm of classical artificial intelligence. Um, and today I decided that I thought it would be great to go through some of the exercises that are provided, and probably even go to a general discussion on the general problem solver, just to see if there are folks who are interested in some of the search problems that it kind of encouraged. Um, Before we begin, a couple of announcements. One is naturally, this is an open discussion for folks. For those of you who are just joining us for the first time, welcome. And just to let you know, if you have any general questions regarding Common Lisp, please, by all means, post your questions on the live stream for those of you who are watching us via YouTube, and thank you for joining. And those of you who are in the Jitsi meetup, please put your questions in the chat room in the chat, and I will address them as I see them. Uh, for those who are members of our YouTube community, thank you for subscribing. Those who are not, if you like what you see, please subscribe. Hit that bell icon so that way you can support us and allow us to create more quality content. As many of you know, Atlanta Functional Programming is a meetup that's in Atlanta, Georgia, that promotes the use of functional programming as a paradigm and kind of discuss some of its best practices and how to create larger architectures that embrace this and its integration with existing paradigms such as object-oriented programming and so forth. We are in need of a new home. Recently, we have been doing the majority of our meetups on the web via for the benefit of the YouTube community as well as those of you who are in the Atlanta area. But we have not yet restarted in-person meetups because we're in search of a new home. For those of you who could provide suggestions to that, please feel free to reach out to me. I'm Bugram on Tech 404, which is the Slack workspace that most of the Atlanta tech community kind of resides in, and provide any sort of suggestions, and we could see how we can schedule in-person meetups at those venues. Additionally, Atlanta Functional Programming is looking for new speakers and new topics, just in general outside of the Common Lisp Study Group, which I run weekly on Saturdays from 1 to 3 p.m. Eastern Time. If you have a topic, again, I am available on both Functional Programming Slack as well as Tech 404 has Bugram. So for those of you who are not in the Tech 404 workspace, you can reach out to me in the Functional Programming Slack and provide me your talk topics, and I'll try and get them scheduled. Also, for those of you who are in the Lisp Discord server, I'm also Bugram on that. If you have a topic in general regarding Common Lisp, feel free to reach out to me, and I will get that scheduled. Any other Lisps too as well. We are welcome to all Lisps, um, as well as Haskell and any hardcore functional programmers out there in other languages. Just reach out and provide your topic proposal, and I will get them scheduled into our into our talk schedule. Um, So last week, I kind of made a couple of mistakes when I was talking about general programming and problem solving, but more importantly about PAIP that I thought I'd at least address now before we start the exercise discussion. One of which is related to um, the where it was actually created. I looked this up later on after our discussion, and the general problem solver was actually created not at Dartmouth. It was actually created as part of the work that Newell and Simon were doing while they were at the Rand Corporation, which is pretty uh, interesting to understand that but naturally, given that Rand was a think tank with creating these kinds of problems, it was kind of makes sense. So there's just a little couple of historical tidbits there that I wanted to kind of bring up. Interestingly, the actual paradigm that general problem solver attempted, ended up creating the field of cognitive architectures. One of which I want to bring up because it's an interesting one that I've actually uh, looked into, and maybe at some point I'll also bring in later on this today's discussion, is the SOAR architecture, which is a cognitive architecture also created by Newell, but it was created by Newell, Laird, and Rosenbaum at Carnegie Mellon. And it's very much in line to how um, general problem solver attempted to actually solve problems with creating these kinds of goals, these generalized agents that could do um, a wide range of tasks, not any specifically specialized tasks. Please, for those of you who are coming in from the ML community, this is very different than what a lot of ML transformer architectures do even today, which is somewhat focused. They've been trying to have the same neural network be trained on multiple tasks, but it's in general somewhat focused into accomplishing a particular task with more accuracy. Well, more precision, not I should be very careful between using precision and accuracy. Um, the other thing that I want to bring up is for those of you who have been following along with PAIP in general and will probably grabbed a copy of the book or are in need of the book, if you actually go to uh, Dr. Norvig's GitHub repository for PAIP Lisp, and I've provided the GitHub URL in the YouTube description for those who are in the live stream, and for those who are in the Jitsi channel, just a reminder, um, uh, the actual URL is. Let me just go ahead and write this up in a Scratch buffer. Um, Hold on. For some reason, it won't allow me to start a scratch buffer until I start up Sly. Give me a second. Okay. And okay. And let's do this. Sly scratch. Okay. And for those who are looking at this, it's at https github.com/norvig/pip-lisp. Now, in this repository, you will actually see two PDF files in there. That's actually the book itself, its content. Dr. Norvig, it looks like, received permission to actually go and post that on his repository. So, for those of you who are looking for the book, it is actually there along with the Lisp code examples, so you don't have to hunt it down. It is available at your disposal. It's actually they're actually in EPUB format and uh, there's also the markdown file that you can actually go and use. I went ahead and did a link into my local repository to actually do a quick load of this project. And if I remember correctly, it's just PAIP. And one second. What is that? PAIP not found. Hold on one second. Did I not? Just a moment. Did I mess up the package name? No, the package name is right. Let me go into my local projects. Grep P. Is it broken? Oh, that's why. One moment. I have to just load up one thing here. Looks like this guy. Okay. And there we go. All right. So I went ahead and created a symbolic link behind the scenes to this project, which I had in a different directory, but for some reason it is unable to find it. 1 second. Let me do a restart here. It should have actually hunted it down. There it is. Okay, quick load. Should be there. Okay, now it is. It just there was a symbolic link to a different project, and I keep forgetting this. If you have a running Lisp image, Quick Lisp goes into your local projects directory, loads all the ASDs, and creates a little cache of all the available ASDs. But if you have a broken symbolic link, it doesn't register that project. And if you go in fix the symbolic link, you have to restart your Lisp image to actually get that to be reread in, so you can actually do a quick load into your objects. It's better if you just go ahead and, for folks who are using Quick Lisp, like I am, as I am especially, to do the git clone directly into the local projects directory. So that way you wouldn't have any of these troubles. But if you try to do some of these complicated, because I have some different registries, I didn't want multiple copies floating around. So I did it this way. Okay, so another thing that I made a mistake last time is, and I'm just going to show this to you, is in the project directory, PAIP Lisp. Okay, so in here, if you go to the Lisp directory, you will actually see not just the solutions to the different problems that we were seeing, and you're seeing many of them, looking to jump ahead for those of you who are interested. But the other thing that is important to note is auxiliary functions. Auxiliary functions include the stuff that we kind of had to add into GPS the other day, last week, and that's mainly because I forgot to actually load this guy in my my Lisp image. And this includes like DBG and DBG intent and all this kind of stuff. So, and requires, and this is the main thing that is important. Requires, what we were talking before, is not a was not a common Lisp thing. It was part of his API that I thought he didn't check in, but it turns out it's because I didn't have that actually loaded into my Lisp image to actually get that loaded in. So we could use this now as part of this, our examples as we are actually going through these. And what's nice about this is it allows us to, work through his examples and, kind of hack through them while still maintaining his loading architecture. We don't have to actually do all that for us for free. So let us go. Hold on. I thought I saw a question here. Okay. So yeah, last week we ended with kind of the end of the demise of the general problem solver. And there was a couple of things that we've kind of discussed the uh, in the interim, such as some of the problems that they were talking about. Plus, we've kind of seen some of the debugging utilities, and that was presented to us by Dr. Norvig. One of which is debug DBG. That I thought we kind of do another quick review of those, because one of the exercises that in the end of chapter 4 is deals with actually re-implementing debug as a single format call. So to work through that, let's first kind of remind ourselves of what this actual um, uh, function looks like. Okay. Give me just 1 second. This is in, I believe this is in, hold on 1 second. This is in auxiliary functions. It isn't auxiliary functions. Hold on a second. Okay. DBG. Okay. So if you look at our debugging output facility that was provided by um, the repository, the actual, and using the examples in the book, um, what it's doing is fairly straightforward. And a couple of things that I kind of mentioned to you before is a couple of functions that most people would probably not be familiar with, just mainly because of the fact that if you're using especially format, it's uh, it's built into the format string. Okay. Now the first thing is naturally the fresh line function. Okay. Fresh line, as I showed last time, is a function that's actually part of the API in Common Lisp. And if you look at its documentation, I don't think there is one. If we look at this, yeah, this is a built-in that is part of it, but it should be more or less self-explanatory. Fresh line means new line. Okay. Um, and sorry about that. Put myself on silent. And its purpose is just creating a new line. There isn't anything else about this. The other thing is important is the way debug is actually written. So if you notice, we have this set of debug IDs. The debug IDs is then identified when we're actually going debug mode. This is very much like how loggers actually work even today. It registers an associated logger with some sort of key value pair, so that way you could filter through those keys and make only those particular log messages be part of the log file that you're trying to create. And the first problem at the end of chapter 4 is well, it is possible to take what we have here, okay, and create a single a version of debug that essentially does this in a single format string. All right. So how do we do this? So let's go ahead and go back to our buffer, scratch buffer. Okay. And let's try this out and see what it is that this is attempting to do. So the first thing is naturally we need to go and check to see what this is what this is doing, how this looks like. So let's go ahead and create a defun, all right, test function, okay, and let's go ahead and run figuring out how uh, sorry out how works. And what this does is one second. I'm getting so frustrated. There we go. Okay. And let's do this and go here. And what this does is we're just going to use a DBG. We're going to call this test naturally, and then say test log message. Okay. Um, and let me actually even do this. Let me just to make it so that there isn't any real like problems with our keyword, although there shouldn't be. I'm going to make this a little more distinctive. So all this is doing is grabbing um, the test debug utilities and printing out a log message. Okay, and that's all it's doing. Now You have to first remember though, what you have to do is when you're using the debugging output utility in this library specifically, as it's been written, is that you need to register that keyword there, that test dbg, um, in um, in the debug IDs that you see over there in the left hand side. And so we need to go in and first obviously um, add ourselves this debug information. Okay, and then we need to then obviously register this, so this way we can actually run this test function. Okay, so here if we do this as is, okay, debug cannot be found. Why can't debug be found? Okay, oh right, it's because I forgot to do requires augs functions. Okay, no, sorry, that's what I want. Undefined. What are you talking about? Wait a second. Oh, I need to do this. Load augs functions, and now it's loaded. So now we can actually load this guy, and now we can run this guy. But this is not actually done yet because we haven't actually registered. As you see, we need to actually go and first register using debug test dbg. So if we actually ran, let's just show this. If I actually ran this here in my REPL as is, you're not going to get anything, and that's because of the fact that we're not actually we haven't actually registered the log message. But now that we have the log message registered, if we go in and run this, oops, um, minus the typo that I just had in there, you end up getting the test log message as expected. But what is it that it's doing behind the scenes is very important. Okay, so we need to actually go and read through and remind ourselves what the debug information is actually doing. Okay, so um, so according to the book, and I'm going to quote this: each call to debug is accompanied by an identifier that is used to specify a class of debugging messages, and the functions debug and undebug are used to add or remove message classes to the list of classes that should be printed. All debugging output will use the identifier GPS, end quote. Okay, so this is basically saying that this is the utility for every example that is provided. So let's go ahead and see what that looks like. Um, okay, right, okay. Um, okay. And let's see what this is, even in one more thing that we may need to read. Stream is debugging input and output. Previous calls format. We use T as a standard output stream, sending to different streams. Allows users more flexibility. Debugging output could be listed inside the window. Blah blah blah. Second, the function fresh line advances to the next line of output. Right. Okay. So one thing that you could do is to actually do this is if you notice the main thing that it's attempting to do is apply format to debug IO format strings in arg. So a naive way of doing this is just simply just saying defun my dbg id format string rest args. And again, we're going to still have to check to see if membership of the ID with our debug IDs. Okay. And if it is a member, then what we'll do is I don't think we can avoid, well, we probably could. We could, let me try this. Debug IO. No, this is going to be two calls to debug IO instead of a single call, because this one would require to add the new line. So, okay, so what we have to do is we have to concatenate a new line to the format string so that it always, so we can eat up essentially the fresh line. So let's see. So now we could try both of these things. So we'll still keep the fresh line first for the time being and not try to do this all at once. And let's go and just do format debug IO. Okay. And then you say format string args. Okay. And for this, we're going to create another test on test add. So this way we have a couple of arguments that we could put into the debug statement. And what we'll do is we'll just say my debug, and we're going to still use the same key. And then what we'll just do is say tilde a plus tilde a. Actually, you know what? Why am I using uppercase? I could still do lowercase here now. Tilde a plus tilde a equals tilde a %. Okay. Now we need to provide a, b plus ab. Okay. Done. So now if we run test add 1, 2, we should get, ooh, okay. 1 second. Okay, so this is not actually splitting it the way we can. So we need to actually, so debug IO is not taking the format string. Okay. Let's see here. Let's do, okay, so let me go look at this. So I might be doing, let me see what the debug indent is doing. Okay, so let me pull up the CLHS's format thing. So this is something new about format that I have to go and look into. So format is t-nil stream or fill pointer. Format control arguments for the control string and the result, otherwise a string. Okay, so in here we could do, and let's see, let's take this guy out. Let's do this, and let's add. Give me just 1 second here. Current. Okay, so is it because it cannot use this format string? Hold on. It grabs the format string. Let me try something here. Format, format debug IO tilde A plus tilde A plus equals tilde A. 1, 2, 3. So this is the correct format string, but instead it is, oh, got it. Got it, got it, got it. The problem is REST actually takes in the arguments into a list, and then it it parsed the list into its individual components. That's the reason why that plus, I mean, the plus AB got evaluated into so the format string that it's getting is not the what this. Instead, what it's doing is actually no, it is getting this. It's since REST actually created this as a list, this A, B, and C. What ends up happening is that entire list gets thrown into the first argument instead of being eaten up. Okay, so I now see why apply was used here. Okay, so what we need to do is we need to create a separate format string that will parse the format string that's passed as an argument, and then we could then apply it, and it will end up doing what we are expecting it to. Okay, so this is, I have to go look up the notation for this. I mean, there is a way of essentially we could do this, for example, but this won't do everything. So like if we do, what is it? plus tilde at, and then what was it? Do format string. I think this alone will end up creating something slightly different. No, tilde at a. Hold on. Too many arguments to format. Okay, hold on. Tilde a. Okay, so if we do this, this is just to prevent it from eating the arguments here. Like I can also do at a here, and this is basically going to split what we want. And if we end up running this, we end up getting that, which is not what we want, but it's getting a little closer. So the first one is basically eating into the second one, but we need to actually now take this list here and have it essentially be used as the arguments into this format string. So that's the second part. And that's going to be pretty freaking weird. Let's see. Okay, observing that introduces a directive. There we go, the control string. Okay, format basic output is an S directive with no parameters. This is a signed directive. So format, for those of you who are just joining us and haven't actually seen what we're doing, is this is a pretty powerful utility. Originally, the way Lisp pretty printing used to work is you had a series of utilities for printing to output. So, and this is just going to be a quick review, just so you understand where I'm going with this. Freshline is basically introduction to these set of utilities. Okay, Freshline was essentially create a new line and print on new line essentially. Line. Okay, and you could think of it as a slash n and going to the next. Okay, and the input was the output will be on the next line. The other stuff that's in this family is prin, prink. You may have seen this at some point, and these are all basically taking in Lisp objects and printing them out. All right. I'm not going to go through all of them just because there's a lot of them. But the point is that they all spit out into a standard a stream. Okay, and the nice thing about the print prink stuff is it will give you the Lisp reader for free. Format, though, on the other hand, is a full pretty printing utility, but requires you to do some parsing and understanding its sublanguage in order for you to get the pretty printing done. Okay, I hope this kind of makes sense for those of you who are following us along. So what we're going okay, so there's a comment here. I think fresh line, brand new line, i.e. if you are nothing. That's right. That is correct. So yes, terminate print is /n. Fresh line is more about dealing with pretty printing the output of the object. So the comment was about the difference between terpre versus fresh line. So fresh line is basically terpre if so. So terpre is just your standard has it stands for is terminate print. Okay, and it is basically /n. Okay. But what fresh line does is it says /n only if we're not on a new line already. Alrighty. This difference is interesting because basically it could shortcut and say, oh, we're already on position 00 of this next line. Why are you asking me to create a fresh line? It will go and print it out. So it is it's useful to have it just in case so that you might if you want to have like tight what is it uh, tight control over how many new lines you have in your formatted output. But the point is these utilities gives you a very line by line way, assembly way of actually setting up your reporting utilities, okay, for your command line stuff. Format, on the other hand, is a sublanguage. It's of the family like loop in many ways, okay? There are directives. For those of you coming in from the printf family, yes, you could think of format as printf, like in the uh, in the common Lisp world. And there's a couple of things that it provides you for um, for convenience. Okay, one of which we've seen. Pre is basically this tilde%. We've seen this all the time. Okay. If we ever wanted this to be like fresh line, though, how do we do this? Well, that's actually just tilde ampersand. Okay, tilde ampersand will give you fresh line. So if we end up doing this, we see that if we try running this down here, oh, sorry, and we try running test add 1, 2, we end up getting the, oh, right, because of the fact that I am using it in the wrong sense here. Well, not the wrong sense, I'm using it in the wrong string. We haven't actually fixed that format string yet. This is where we'll have fresh line. And this replaces the fresh line that we saw earlier in that code. So now if we do test add here and we run it, we end up getting, oh, hold on. What the hell? Okay. Should we tilde ampersand, right? Okay. Let's see this. So you could do this 0 ampersand. It doesn't really make, it's really not needed, but what this makes it more explicit. If we do this, let's see. Okay, so this here is actually not doing what I expected to. Hold on. This is personally text. Okay, so let me go back to this here. And let's go in and look at the other thing. Because we're already at 0, it's not it's still spitting it out, but I think the only reason is because of the fact that since I'm not already on you can see that the new line is working here. Again, this debug IO ampersand stuff is it should have worked, but it's because it's not parsing the previous one, that it's trying to understand what I'm trying to do with the first argument in with respect to this format string, that it's not actually evaluating the tilde ampersand as we're expecting right now. So this is so line 11 and line 14 are still somewhat broken, and so I'm gonna for the time being, as we're going through this, we're gonna be using the REPL just to kind of get ourselves um, a little more flexibility to play around with a couple of things. Okay. Are there? Okay. So just like tilde ampersand, for those who are writing to like using Lisp for like printing, which you could, there's also a format just to show you how versatile this is. There's a format tilde ampersand. Sorry, tilde pipe. And what this does is it actually creates a page separator. So that control L there is a page separator if you end up actually printing this out into like a scribble, and then you want to print it out. Your printer will recognize that it has a new page and then print it out, is my understanding of how the page separator works, which is kind of nice. Um, tilde C again, and I know this is probably somewhat a review for those of you who are familiar with the format character, but it's been a while since I've actually gone through the format sublanguage. So the tilde C is if you want to print out a specific character, which you could certainly do so. Um, that might be helpful for us in what we're going to do next, in trying to print out the format. But we will. Let me see if there are other options. Um, Standard aesthetic, standard and right. Okay, no, I know about the aesthetic. I'm always going for that one. Pre-printer operations. Let's see here. Tilde underscore conditional new line. Fail mandatory without any modifiers. Hold on, what's then? Logical block. This is a pre-print logical block. Ah, here we go. So in debug indent, so we're going to combine debug indent and debug in our format. So let's see here. Let's try here in our buffer, sorry, our Lisp REPL, format debug IO tilde ampersand tilde, let's see here, on indent. So let's say that we want to say it's we could do an indent, but this doesn't really. Oh, sorry. I should have done this with a. We could see that it's actually getting indented in from the CL REPL, because normally if you do format debug, sorry, IO, and then you do tilde A, and you say 5, notice that the position of the 5 in the REPL is actually in position 0, and this is now a 2-space indent. Now, if we want control over that, we're going to also have to deal with passing in indent as part of the format string. So this is actually pretty useful to keep in mind. This is probably something we may actually end up needing. We could also call a function, but we don't need to call a function for this for the time being. Okay, so what else can we use here? We have um, layout control, tilde t, tilde less than, tilde greater than. That's not what we need for the time being. Um, okay, so let's see, control, tilde question mark, tilde right brace is a conditional. Oh, right, that's an iteration. Okay. And okay, here we go. There's also the next argument must be a format control, otherwise, and the one after that, a list. So, oh, so this is nice. Okay, this might help us. We have something called, what is it? Tilde question mark, and then we could do that. Maybe this gives us something. Oops. There we go. Test. So what tilde question mark does is it's a recursive call in the format sublanguage, and it will take in a format string and then spit it out. So ideally, this should give us what we wanted, which is 1 plus 2 equals 3. So it eats our format string and it'll actually go and spit out the thing. But we're not completely done yet because we still need to deal with two other things in this format string to actually complete it, which is fresh the indent piece here that you see in line 288, which my debug is actually essentially combining. So this is basically implementation of indent. So we can actually add in here a different version, which will take in one more argument. So here, do this. One, four. Okay. And we need to now pass this guy over to our utility. And right now I'm going to just declare this ignore indent just because otherwise it's going to give us a warning. The compiler is going to give us a warning. Oops, sorry. Let me do this. There we go. So that's a new function. This is the same function. All right. And in this one, we need to figure out essentially how do we pass indentation into it. So we saw that we could do indent with tilde I, but there might be another way of getting us there. So let's see. Miscellaneous operations, left paren case conversion, right paren case conversion. Okay, right. I'm hoping those who are watching sees how versatile this format library is. There's a lot of options here. Much like in many ways printf. Printf actually has quite a few options too as well, and I think some of the um, tilde immediately followed by a new line. Ignored the new line. No, this is not what I want. Tilde circumflex is escape upwards. Still an escape construct. So clause separator for, so tilde semicolon is a clause separator. The other one is, let me see the miscellaneous operations. Tilde play plural. Oh, okay. So if we want to actually create plural nouns, we can actually add that. Okay. Okay. Let's see here the other examples of format. Let's see. Tilde. So let's see if there's a control flow operations. Tilde asterisk. Go to conditional iteration. No, no, no. Iteration gives us a brace. That's not what I want. We want you can do tilde. Let's try this one thing here. I was hoping I can actually take in and pass in an argument into indentation. And let's see if I could just do, no, indentation is just, tilde I is going to give us an indent, but is that what we want? We want spaces actually, right? Tabulate, tilde T. Ooh, wait, tabulate. That's probably what I need to look at. Tilde I, layout control. There it is. Tilde T. This bases over a specific column. Okay, if the cursor is beyond column number, it will move output spaces to column plus K. Okay. At T prevents relative tabulation. Okay. And could I do this? Let me try this. format T tilde no, we need T. There we go. Well, we can do lowercase too as well. And let's say 5. And so 5 spaces in relative tabulation. And let's print out a 6. So what does that do? Interesting. So it didn't actually do what we expected it to. T. Let's see here. Nope. Okay. So what I need to do is, let's see. So it's not just any other any run-of-the-mill thing. What we're gonna have to do is there's probably, is there like a, let me go look at that documentation. What if I want to pass it in as an argument? Okay. Let's try. No, this is just giving more fuel to the fire. This is not what I want. This is, let me see if I do that. Ah, okay. So what is in the hyperspec? Okay. Okay, let's see here. Levy. Okay, so well, I just wrote in the command window. I had to remind myself of what that prefix parameter is for our thing. A prefix of v is special to format in that it consumes one of the arguments that are being passed in and then uses that as a prefix parameter. You can't just use any old prefix parameter name in X. It will go ahead and then grab that format and use it, but it doesn't use it as a prefix parameter to inform the at t argument, the tabulation argument that I was trying to create here. So a prefix of v is, so tilde v is a very special thing. It's a prefix parameter for any um um any what's it, any format operator that's inside of the control string. So if we wanted to say 5 spaces, sorry, 5 indents, we could use the same thing if I'm not mistaken. So tilde vi tilde a 5 6, and it'll give us, hold on one second. It ignored it, but it should have indented it. Let's see. The at sign cannot be used with this directive. Okay, that's weird. Let's see if I do. Sorry, not the at sign. Go here. Change this to Okay, so 6 is even being ignored. Um, 1 second. Let me try. We did tilde I, tilde A. We end up getting 5. Now let's say that I do. Oh man, what is? Go back to pretty printer. Indent. Indent is the same. Okay, it's the same as pretty print block. Okay, so hold on. Let's try one thing here. Do 5, the I, A, 6. It's 56. Interesting. Okay. I need to figure that one out with the indent for some reason. But the variable I at t is, I think, what we need here. So let's try this in my indent. Do tilde v at t. Do that. Requires yes, of course, because I forgot to pass in the indent. Okay, now I think this is our final version here. And if we run now test add, test add 2, we now get 3. So let's go ahead and do, oh, wait, I'm using the old one. I have to change this to my debug indent. Indent. Add 5 spaces. And if we run this again, you see that everything gets pushed in. So now, what is the, okay. Interestingly, this is exactly the format string that I believe Norvig uses in his answer. The tilde v at t, tilde question mark, because that's what's needed to determine between tabs versus spaces. So this is a very concise, as you can see, with the actual code compared to what we had to write in debug indent. It's very concise and very to the point. Now, yes, for newcomers who are actually uh, leveraging this, okay, format is daunting. I will not tell you that this it takes a while to get some really nice formatting recipes. But if you once you learn the sublanguage, it basically works whether you're dealing with formatting to a stream. As I mentioned before, there are even paper like line printing like commands to do formatting in. So it gives you a lot of versatility, a lot of flexibility. So and this is exactly what if you looked at and learned Common Lisp like I did from Practical Common Lisp, Chapter 18 of Practical Common Lisp goes through this quite a bit. I actually had to go back to it to remind myself what the prefix parameter was for. So still very relevant today for those of you newcomers that are sticking around and trying to learn Common Lisp. Um, Always something to kind of remind yourself to do when you're working on these. Um, are there questions about this particular example? Okay, so let's go to the next problem, which is writing a function that generates all the permutations of its input. Writing a function that takes all its permutations of its input. Okay, so permutations means um, no repeated elements. Um, okay, I think I understand. So if you're doing right, so I got to remember permutations versus combinations because in one case you have repetitions, the other one you don't have repetitions. So this, to give an example of what this is for folks who need a refresher like I do sometimes about this, a permutation is like given a bag of numbers, let's say 1, 2, 3, okay? Um, you cannot um, repeat. So 1, 1, 1 is not a permutation, but 1, 2, 3 is, if I'm correct. I think that's correct. Or is that a combination? Oh man, sometimes I have to remind myself. Um, right, that's right. 1, 2, 3 is a permutation, but 1, 1, 1 is not. So you don't get any um uh you cannot have repeated elements. You can't use the same element time. Um so the so this is asking for essentially for us to create a uh, given a bag of elements, create a list of all the permutations that it has. Um, so there are two cases. Let's go ahead and define our function. Define permutations because and let's before we do anything, I always should make sure that there isn't a built-in anything like this here. And there isn't. Let me do an apropos. No intern symbols. Oh, I just interned it. Ah, dang it. That is not what I wanted. Okay. Okay, so there are no values. Okay, so now we could simply write a pretty naive case of this. Basically, if you have a a this can be written as a uh and let me just go ahead and write the turn list of permutations. So you have two cases here. One, the bag is empty. Okay. Um, I'm just using bag of values generally. Although I think the answer also uses a bag. Um, you know what? I don't like this analogy. I'll just say input here. Okay. Um, list. Okay. This is much better. Okay. So now we have two cases here. One, oops. Okay. If we are dealing with a null list. Well, if there's no list, that means you have no values, right? So essentially, you have to do, you're just returning a, an empty list. And it's going to be a list of, remember, it's a list of permutations. So each list is each permutation is itself a list here, okay? So one of the things about Common Lisp, if you recall, is we have a family of map functions, and one of the map functions that will come in handy for us is essentially the map that can take a list of lists and flatten the list for you. So um, and the one that I'm thinking of is so let me just go and show you all the map functions first, if you recall. Um, where are you? Dang it. Hold on. Let me do this. This is probably clear. I want not map. Let's do map CA so it can give me. There we go. You have map car and map can. I think map can is what I'm thinking of because we used this before. This basically applies function to successive elements of lists of more lists and then gives you the nconc. Yeah, so the nconcatenate of this return value. So it flattens it by just getting the list of lists and then um, concatenates them into a single final list. Okay, so what we're going to do is uh, we're going to construct a list. Okay, so we're going to use map can. Okay, here. And map can is just basically going to construct a list of our permutations. Okay, it's going to create the list of our permutations, our final list of our permutations. Okay, and what it's going to do is going to take in an argument. Okay, um, with the first argument, right? So let's call this x because I always like. And this guy is going to go in and construct our cons list. Okay, so it's going to construct essentially the uh, permutations, um, assuming that x is removed from the list. Okay, so we're going to use a recursive call to actually go and construct this. Okay, so one way of doing this is pretty simple. This is going to be a cons of it's so this is going to be essentially itself a map car, okay, of another lambda itself is going to be taking y and we're going to cons x with y. Y is going to represent the permutation, okay, the remaining permutation of the remaining values, okay. And what we'll do is to construct this guy, we're going to actually pass the recursive call of permutations with the remainder of the list. Now, you might think that you could just do rest of one way of doing this is probably just doing the coder of yeah, we could just do the rest of LST, but there's even a better way of doing this too as well. Um, and then but I think it's the rest. I could just do the rest and then this should work. Um, but we could then see what other ways of doing this. Okay, map can, and then our arguments to this is the LST. So let's see what happens here. Let's moment of truth, everybody. One, one, two, three. No, that's not what we want. This is not. This should have Let's see. We could remove the item from the list. Okay. Making sure that the we only grab the because remember in describe, hold on, let me describe this guy. Remove. We're going to remove a copy of a sequence with elements satisfying that the default item is removed. Okay. Let's just say if we use test instead of that, we'd use EQ. Let's see what that does. Oops. Let's see this. Much better. So 1, 2, 3, 1, 3, 2, 2, 1, 3. Yeah, all 6 elements are done here. The one thing here, yeah, this is correct because this is now a list of lists, as you can see here. Now, there is a couple of other things that you could do here. Like if you use DQL by default, I think this also should work because that I think is the default as we saw earlier with the remove, but I don't know. Let me see. I'm pretty sure this would work too. Yeah, this also would work. EQ and EQL work very similar, but the map cans is basically the same idea. Um, let's take a look at now uh, so these are all related to. So the next question is really talking about general problem solver itself. One is talking about and this might take us a little time to actually go and solve, which I think we're running out of time for today's episode. Um, and I'd really like to spend some time to debug into this. But just for food for thought for those of you, these are all pretty interesting ones that we might go through next week too as well. This one here is talking about that general problem solver in general, no pun intended, sorry, does not recognize a situation where a goal is accidentally solved as part of achieving another goal. Now, we saw this actually last week with one of the examples where I believe it was if you have money and have a taxi and you need to take your son to school, it was you ended up either not having money because you gave the person to a taxi, and you still already had leftover money, and the son was at school, or it ended up going being the situation. Actually, let me just double check that. I think it was the situation where basically, where did it? I think it was taxi. 1 second. Right. So this is related to the not looking after you don't leap problem, which there's another problem in the exercises that we can go through. But the idea is if you have, taxi son at school, son at home and have money, and your goal is to get your son to school, okay, with the school operations that we saw last week. Um, if you were encountering a problem where, let's say that you want to take your child to school without using any money, okay, and you have a card that works at home. Currently, the way the general problem solver attempts this is that it ends up it always ends up driving the son to school, and that's because it's a bit eager in first accomplishing the goal without looking at all possibilities. Um, and the example that they give here, to give even more context into this problem, is consider the goal of eating dessert. Um, the two operators that he provides is eating ice cream or eating cake. Okay. Um, eating ice cream requires having actually ice cream. Eating cake requires actually having cake. Okay. And I assume you can buy the cake. Bakery has a deal which gives you free ice cream. All right. In this scenario here, the goal of eating dessert now gives you two options, either by eating cake or eating ice cream. All right. Um, and it's basically uh, if you have ice cream already at home, because this bakery gives you a deal to give out free ice cream, GPS will decide to eat the ice cream, go buy the cake to get the free ice cream, and then go ahead and eat the ice cream, even though the goal of eating dessert has already been achieved by eating the cake. All right. So GPS, because you want to go and eat the ice cream, all right, and you want to go to the bakery to buy the cake to get the ice cream, instead of eating the cake, you're gonna go and eat the ice cream instead, because that was what you were intending to go. And so you have to go and fix essentially GPS so that your goal of eating desserts, which gives you the option of eating and or. Um, so in this case, eating cake or eating ice cream, the goal was already achieved by buying the cake and eating the cake. All right, so we need to go and actually think about how to design the operators in order to represent the situation to then fix GPS to actually solve this problem. So it's going to take us a little bit of time to actually construct this, and then discuss how GPS does this, and then debug its needs. But since we have 9 minutes left for today's session, I'm going to hold off to that to next week, so we can actually have a more thorough discussion about this. So with the 9 remaining minutes, I'm going to open the floor to questions just to see if there are any in general about Common Lisp or what we're covering. Okay then. Thank you all for joining. Next week, we're going to continue our exploration of these exercises. Hopefully, we'll also get started on dialogue with Eliza, which is a personal favorite of mine. Natural language processing is a bit of a hobby for me. So this is going to be the first. That's actually one of the first systems to deal with conversation. We're going to have a lot of fun with that. Um, please, you know, join us in the discussion if you can, on Saturday, 1 to 3 p.m. And I hope you guys all enjoy your Saturday afternoon. Um, please like and subscribe to our channel. And for those of you who are willing to give talks, please reach out to me at Bugram at Tech404 and or Functional Programming Slack. I hope you all have a good weekend. Bye.